Foreign technology continues to develop, facilitating our research into the great unknown that is space. As we develop more and more, it's only a matter of time before the discoveries we make take the world by storm. So today, here at Unexplained Mysteries, we'll be taking a look at 3 new astronomical discoveries made thanks to some phenomenal technological developments. James Webb Space Telescope. The James Webb Space Telescope has begun to capture the hearts of many, just like Hubble did before it. Setting off to flight in December 2021, the James Webb Space Telescope has begun to provide tremendous observations and already has a whole list of research opportunities just waiting for it. In July, the wonderful talents of the telescope were shared with the world when NASA released the first full-color images provided by the telescope. Though, of course, this is not where the magnificence ends. Since the initial buzz of what Webb can do, we have seen it gather shots of evidence of a supernova, of carbon dioxide in the atmosphere of an exoplanet, and even an Einstein ring. An Einstein ring is formed when the light of a galaxy or star passes by a huge object as it travels to Earth. This then experiences gravitational lensing, meaning that the light is diverted. This creates almost an illusion where the light looks as though it has different origins if the source, lens, and the observer, in this case the James Webb Space Telescope, are lined up perfectly, then a ring will form. This is a somewhat rare occurrence, so it's without a doubt an exciting opportunity to see with such clarity like this. The JWST has brought us a picture-perfect view of the galaxy SPT SJ0418-47518. Well, not quite. It looks as though we are seeing an Einstein ring from this galaxy, but it's the light bending around a galaxy in front of it, closer to Earth. So it's not the initial galaxy forming the light as we might expect. Regardless, we might have spoiled the magic a little bit, but it doesn't take anything away from a breathtaking photo. Water-world exoplanet. One part of space exploration that is particularly fascinating is the search and discovery of planetary bodies. When we are lucky to stumble across those outside of our solar system, we call these exoplanets, and this has been the focus of plenty of recent research. Research published in the Astronomical Journal in mid-August 2022 details a discovery in which researchers believe they might have uncovered a new exoplanet that has been dubbed a water world, thanks to the possibility that the surface is entirely covered in water. It was an international effort that went into the discovery of TOI 1452b, with a team being led by Charles Cadia, a PhD student at the University of Montreal and member of the Institute for Research on Exoplanets, IRX. The primary equipment used to detect the initial signs was the Transiting Exoplanet Survey Satellite, TESS, operated and made by NASA. This water-world exoplanet was found approximately 100 light-years away from Earth. It appears to be orbiting one star out of 2 that form a binary system, which can be traced to the Draco constellation. A binary system is when 2 stars orbit one another, forming one system together. This water-world planet orbits one of those in the system, not too dissimilar from how Earth orbits the Sun. The distance from the stars means that the surface temperature of the planet could facilitate water, making the possibility of an ocean planet fairly likely. They believe that the surface of the planet could simply be a thick layer of water, comparable to some of Jupiter's and Saturn's moons such as Enceladus or perhaps more notably Europa. TESS works by detecting fluctuations in the brightness of a star that might indicate an exoplanet is passing in front of it. It surveys the whole sky with the primary aim being to detect planetary bodies similar to our own, though it does not hurt to find interesting ones like this too. The TESS detection indicated that this planet may be about 70% larger than the Earth. This was calculated due to the decrease in brightness being picked up every 11 days. While TESS might have first picked up these signals, it wasn't just one piece of equipment that took on the work. René Doyen, a professor at the University of Montreal and the director of IRX and of the Observatoire du Mont Mégantic, explained that a new analytic method was applied in the OMM lab using a special instrument that allowed for these further conclusions to be drawn about the exoplanet. With TESS simply alerting us to its presence, it's this further research that is required to confirm the type of planet it is, as well as other possible characteristics. Another piece of equipment that is helpful in determining some more of these characteristics is PESTO, a camera installed on the OMM telescope. PESTO was useful as the resolution is high enough to distinguish between 2 objects, something beyond the capabilities of TESS. This is an impressive feat considering how close together these astronomical items are, with the stars sitting just 97 astronomical units apart. An astronomical unit is equivalent to 149.6 million kilometers. Pesto managed to provide images that confirmed which of the two stars are being orbited by this water world. As far as we know, TOI 1452b could in fact be a rocky planet much like Earth, though the characteristics that have been identified, namely the mass, the radius, and the density, indicate something much less like our own planet. We know that the surface of Earth is predominantly water, clocking in at 70%. With regard to the mass of the planet, water plays a very small role, accounting for less than 1% of the Earth's mass. That is what could make a difference between Earth and this potential water world that has been discovered. The densities that are being observed in these exoplanets can only be explained if the materials that go into the composition of these exoplanets are much lighter than those that make up the Earth's internal structure. These are theoretical concepts that would explain the makeup of planets that could be like this. Water is a significantly lighter component than what Earth is made up of, so it's one of many hypothetical explanations as to how the mass is so light compared to the radius of these planets. The name given to these places is ocean planets, but we do not know if they even exist. The lead researcher said that this is perhaps one of the best candidates for an ocean planet that has been found so far. He said its radius and mass suggest a much lower density than what one would expect for a planet that is basically made up of metal and rock like Earth. The potential ocean planet water world is a perfect example of how utilizing different tools and expertise can help to provide different insights into the planet. The JWST could be a brilliant opportunity to take a closer look behind the scenes of this world. Scientists discover a toxic cloud on the surface of Venus. NASA's Parker Solar Probe is the first spacecraft that is on a mission to touch the Sun. In reality, the aim is for it to make observations of the outer corona, providing us with more details about the star. The mission launched in 2018, though in early 2022, the probe has actually provided us with more information on Venus than it has on the Sun. The Parker Solar Probe seemingly uncovered a hot surface lurking beneath a cloak of toxic clouds. This discovery of the hot terrain could help us to piece together our understanding of the minerals that are present on Venus. Data obtained using the Wide-Field Imager on the Parker Solar Probe revealed something beneath the thick atmosphere as researchers were able to take a peek and spy highlands, plateaus, and plains. This information on the geographical features of the planet was thoroughly exciting, letting us see the surface from space in visible wavelengths for the first time. We know that Venus is home to rainfall of sulfuric acid and toxic clouds. Despite how fascinating this is, it's been a cause of significant scientific hindrance in the past, causing great difficulty whenever the planet has been investigated. These clouds make it much harder, yes, though evidently it's still possible with the opportunity to take a glance behind the curtain. One cannot help but wonder what more there is on this planet for us to uncover. Yes, but what do you make of these new discoveries? Be sure to let us know your thoughts in the comments section below and help us by growing this community while working to solve these unexplained mysteries. Space exploration and technological advancements. The realm of space exploration continues to be driven forward by remarkable technological advancements. These innovations not only expand our understanding of the universe but also pave the way for groundbreaking discoveries that capture the imagination of people worldwide. In recent years, space agencies and private companies alike have focused on developing advanced telescopes and spacecraft capable of unprecedented observations and missions. One notable achievement is the deployment of the James Webb Space Telescope, JWST. Launched in December 2021, the JWST represents a significant leap forward from its predecessor, the Hubble Space Telescope. Equipped with cutting-edge technology, the JWST aims to capture high-resolution images and gather data across different wavelengths, providing astronomers with insights into the early universe, exoplanets, and other cosmic phenomena. The JWST's ability to observe in the infrared spectrum enables it to peer through cosmic dust clouds and study distant galaxies with unparalleled clarity. This capability has already led to remarkable discoveries, such as the detection of gravitational lensing effects, including the elusive Einstein rings. These phenomena occur when the gravitational field of a massive object bends light from a background source, creating a ring-like structure when viewed from Earth. Such observations not only validate Einstein's theory of general relativity, but also offer new avenues for studying the distribution of dark matter and the formation of galaxies. Moreover, the JWST has provided detailed insights into the atmospheres of exoplanets, planets located outside our solar system. By analyzing the light passing through exoplanet atmospheres during transits, scientists can identify the presence of key compounds such as water vapor, carbon dioxide, and methane. These findings are crucial for understanding planetary formation and habitability, informing future missions aimed at discovering potentially Earth-like worlds capable of supporting life. In parallel to astronomical discoveries, advancements in propulsion technology are revolutionizing space exploration capabilities. Initiatives like NASA's Artemis program aim to return humans to the Moon and establish a sustainable presence, laying the groundwork for future crewed missions to Mars and beyond. Key to these endeavors is the development of advanced spacecraft, habitats, and life support systems capable of withstanding the harsh conditions of deep space. Commercial space companies, such as SpaceX and Blue Origin, are also playing pivotal roles in expanding humanity's reach into space. SpaceX's Falcon rockets and Dragon spacecraft have significantly reduced the cost of launching payloads into orbit, facilitating satellite deployments, resupply missions to the International Space Station, ISS, and future crewed missions to low Earth orbit and beyond. Similarly, Blue Origin's New Shepard and New Glenn vehicles are poised to enable suborbital tourism and commercial satellite launches, further driving innovation and accessibility in the space industry. The quest for extraterrestrial life remains a compelling driving force in space exploration. Recent advancements in astrobiology, the study of life beyond Earth, have focused on identifying potential biosignatures, indicators of life on distant planets and moons. Missions to icy moons like Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, have revealed subsurface oceans beneath their icy crusts, raising the possibility of microbial life existing in these extreme environments. Future missions, equipped with advanced robotic probes and sample return capabilities, aim to explore these moons and search for definitive evidence of life beyond Earth. Furthermore, the study of planetary geology provides valuable insights into the formation and evolution of celestial bodies within our solar system and beyond. The Parker Solar Probe, launched by NASA in 2018, has revolutionized our understanding of the Sun's outer atmosphere, known as the solar corona. By making close approaches to the Sun, the probe has collected unprecedented data on solar wind dynamics, magnetic fields, and solar flares, critical factors that influence space weather and impact satellites, spacecraft, and infrastructure on Earth. Beyond the Sun, planetary missions continue to unravel the mysteries of Mars, Venus, and other rocky planets and moons. NASA's Perseverance rover, launched in 2020, is actively exploring the Martian surface, searching for signs of ancient microbial life and preparing for future human missions. The European Space Agency's ESA Bepi Colombo mission to Mercury is studying the planet's magnetic field, surface composition, and geological history, shedding light on its formation and evolution. Meanwhile, the study of Venus remains a priority for planetary scientists, despite its inhospitable surface conditions. Recent observations by spacecraft like ESA's Venus Express and Japan's Akatsuki mission have revealed dynamic atmospheric phenomena, including sulfuric acid clouds and superrotating winds. Future missions, such as NASA's Veritas and Da Vinci Plus, aim to map Venus's surface and atmosphere in unprecedented detail, providing new insights into its volcanic history and potential habitability in its distant past. Advancements in space telescopes and ground-based observatories continue to expand our understanding of the cosmos. The construction of large-scale telescopes, such as the Giant Magellan Telescope, GMT, and the Extremely Large Telescope, ELT, promises to revolutionize observational astronomy by providing unprecedented views of distant galaxies, black holes, and the cosmic microwave background. These facilities will enable scientists to probe the origins of the universe, study the nature of dark matter and dark energy, and explore the possibility of multiverse theories. Moreover, international collaborations, such as the Square Kilometre Array, SKA, are advancing radio astronomy by constructing the world's largest radio telescope array. Spanning continents and involving multiple countries, the SKA will study cosmic phenomena, including pulsars, black holes, and the formation of stars and galaxies, with unmatched sensitivity and resolution. In conclusion, the future of space exploration is driven by technological innovation, international cooperation, and a profound curiosity about the universe. From the deployment of advanced space telescopes and robotic missions to the development of sustainable human habitats on distant worlds, humanity's journey into space promises to unlock new frontiers of knowledge and inspire future generations to explore, discover, and understand our place in the cosmos.